Hi and welcome to this third video in this section on log laws and using logs. And in this video we're going to be having a look at how we can solve equations using logs. That's equations that involve indices or equations that have actually got logs in them from the start. So essentially like kind of two different types, and here's the first group, which is those equations that have got the thing that's missing, the thing you're trying to find is the power. So two ways of going about these. Now I'm a little bit old school in that I learned to do these kind of things before the newfangled calculators were able to deal with different bases, because originally calculators were only able to deal with base 10 and you just had the standard base 10 button. Now that you've got a button on your calculator that can deal with any base, these things become a whole lot easier. But I'm going to show you both methods anyway. So the first method, let's say, is my old school method. So what we're going to do is something called, we're going to take logs of both sides. Now, I said this was a bit old school, but this is a technique, and this is something that will be very useful, particularly next year. So this idea of taking logs is a really useful thing to begin, regardless of what you can and can't do on your calculators. So here we go. What we're going to do is say, well, if I've got 2 to the power x equals 12, then I know this value here is the same as this value. So therefore I know the log of this is the same as the log of that, because these two things are the same. So what I'm going to do is just write the same, say log of 2 to the power x equals log of 12. Now notice I haven't put the log in there. Your calculators do still default to base 10. It really doesn't matter. The choice is kind of irrelevant because it will work regardless. But what we're going to do is say, well, if I've got this statement here, now if we have a look at this one here, you can see we can use law 3. And let's say this is how I get hold of the exponential and bring it down into the equation. So I've now got x log 2 equals log 12. So this is x times by something. This thing here is just a number. So I can just treat that in the same way as any other and just take it over the other side and do a divide. Now the key thing here that's popped up in red is the fact that we saw previously that we had log 12 over 2, which is log 6. That is not the same as log of 12 divided by log of 2. And again, it's well worth just having a little punch of buttons on your calculators to satisfy yourself that those two things are not the same. So we're not doing the log of 6 here. So what we'll do is just grab the calculators, type in log 12, type in log 2, and out pops your answer, 3.58. Now that was the slightly long-winded method for this particular one, but as you'll see later, that taking logs idea is really useful. But if we're doing it now on a calculator that can deal with any bases, all we've got to do is take that sentence there, rewrite it using logs. So we're going to go for log to the base 2 of 12 equals x. There we go. And then all you've got to do is just type that into your calculator, which is a whole lot more straightforward than what we saw on this side of the screen. But as I keep saying, this technique, don't ignore it. Don't just think, okay, we don't need to do that because I've got my calculators. That technique over here is really useful and you do need to know it. Okay, so there's the first one. On we go. Part B, there it is. So all I'm going to do with this one is just say, okay, let's just rewrite that statement using logs. So we've got logs to the base 6 of 2 equals 3x minus 1. And again, the key thing is that this value here is just a value that we can get out of our calculator. So therefore, 3x minus 1 is 0.3866. That's that value there. Log to the base 6 of 2. And then it's just a case of add 1, divide by 3. And there you go. There's your answer. And the final one, we've got 3 to the power 2x minus 1 equals 5 to the power 4x. Now, just be a little bit careful with this one because what we've got is different bases, so you've got to be a lot more careful. And in this case, it is simpler, I think, to take logs of both sides. But having said that, you can do it using a similar technique to this one, but you just got to be a little bit more careful with what you're doing with your powers and bases and so on. But I'm going to take logs of both sides. So here we go. There it is. The log of that thing is going to be the same as that because these two things are the same. So now we can just take our powers here and just bring that down to the front. Same on this side. So we've got that. Now what I'm going to do now is make this equation say x equals. So again, remember that log 3 is just a number. So I've got a number times by a bracket here. So we can multiply out the bracket. So that left hand side becomes 2x log 3 minus log 3 equals 4x log 5. I've now got to get all the x's together. So I'm going to bring the 4x log 5 over here. Take that log 3 out the way over the other side. There we go. What we've got to do now is a little bit of factorising. So take out the x. So we've got x 2 log 3 minus 4 log 5 equals log 3. And then finally, all we've got to do now is just take this entire bracket and take it over to the other side. There we go. And now you've got something, just whack that into your calculator. And there's the answer. That's it. At this point in time, you might want to just kind of pause the video and see if you can do this equation here using the same process that we used over here. Entirely doable, a little bit more complicated, but whichever way you do it, you will end up, if you get it right, with that answer. Okay, so those are our first type of equations where we are using logs to kind of help us deal with powers. Right, let's put that into context, and here's a question that you might have actually seen at GCSE, and at GCSE this is a compound interest question, and they do occasionally pop up, and essentially at GCSE they just expect you to blast some numbers into a calculator and do it in a kind of trial and error type of a way. But we're going to be a little bit more precise and a bit more technical than that. We're going to do this question using our log laws. So here we go. So set up the question. There we go. So there's our principal amount to begin with, 5,000, and a compound interest, 4.5% each year. So we know we've got 5,000 times by 1.045 times by 1.045 times by 1.045 and so on and so on. And we know we end up with £7,110.50. Okay, so how are we going to do it? Well, let's say at GCSE, it was just a case of pick a value, chuck it in, see how close you get, and then adjust it until you got to the right answer. Now, what we're going to do is just solve it. So we're going to take the 5,000 over to the other side, do a divide. There we go. And so now let's use our log law. So I'm going to take logs of both sides, use law 3, and then just do divide by the log. There we go. So we've got log 1.4221 over log point blah 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 blah, decimal whatever. Chuck it into your calculator, and out pops the answer. Happy days. Okay, moving on. Tsetse flies transmit African whatever that is, sleeping sickness, to animals and humans in surrounding countries. So we've got population model here, and it says that the population increases by 7% each week after the end of the monsoon season. So how long does it take for the population to double? Right, on we go. So let's call P the size of the population. So what we've got is our original population increasing by 7% each week, and we want that to be double the original population. So there's the equation that we can set up. And now if we just divide both sides by P, we end up there. So as it turns out, the initial size of the population is absolutely completely irrelevant because we're interested in how long it takes to double. So how many years will it take for this multiplier of 1.07 effectively to become 2? Again, old school, I'm doing it taking logs. You can choose whichever method you want. Bring the n down using law 3, do the division, and it takes 10.244. So approximately how many weeks it take? Well, it won't have doubled after 10 weeks. It'll take it 11 weeks. It's actually doubled, but kind of depending on exactly what the question says, you either end up kind of rounding up because it hasn't physically doubled at the end of 10 weeks, and it will take at least 11 weeks to double. Or if it just says approximately how many weeks, it would be okay to write that as approximately 10 weeks. But let's say those kind of questions, just read the question carefully and do exactly what you're being asked for. Okay, so there we go. And moving on to the second type of equation, and those ones that actually contain logarithms initially. So the key to these is to get them written as a single log. So use your log laws to bring all the logs together, and then essentially just reverse the process of taking logs. So what I'm going to do is, starting off with this equation here, is take my 2 log 3 and reverse law 3. So write that now as log to the base 3 of x squared. We know using law 2 that this can be written as a single log. Again, but bear in mind this will only work when I've got the same base. If these are different bases, you can't do it. You'd have to do something else. So we can write it like that. And now if we reverse logs, we're saying that our base is 3. So the power 2 is this thing here. So we've got 3 to the power 2 equals x squared over x minus 2. And so 3 squared is 9. Bring the x minus 2 over, multiply it all out, turn it into a quadratic, and solve the quadratic. And there you go. So like I say, kind of key idea there, bring all the logs together, and then just reverse your logs to write it using powers. On to the next one. So we've got that equation there. So again, what we're going to do is bring all the logs together. So this minus 4, I'm going to take that over, so I'm going to bring the log to 2 log x over to that side. Okay, so now we can use again our reverse power laws there. Same principle as before. Write it as a single log using law 2. And then we've got 2 to the power 4 equals x plus 15 over x to the power half. And multiply it out. Now, at this point, you've got two ways of going about this. You can either rearrange that so it says 0 equals x minus 16x to the power half plus 15, and then factorize it from there, which is perfectly possible. Or the alternative would be to square the entire thing, and that's the version I'm going to go for. So if we square both sides of the equation, we've got 256x equals x plus 15 squared. Multiply out the brackets, bring the 256 over, we've got a quadratic. Factorize the quadratic, and again, if you didn't spot the fact that that would factorize, then you can just plug the values into your polynomial solver on your calculator, and so therefore you've got your two values. Job done.